Hi students, you are welcome to the continuation of the online tutorial class from the Student ScoreBooster video tutorial, your online tutorial provider on JAMB, WAEC, NECO and NAPTIP exam. Today will be the continuation of our physics lecture. And for today's presentation, which is the second presentation of our physics, we'll be focusing on Newton's laws of motion. I am Bangbade A. Before we continue, we need to consider the learning outcomes of the objective of this presentation, which goes thus. At the end of this presentation, listeners should be able to state the Newton's laws of motion. Also, listeners are expected to state the law of conservation of linear momentum. They should also be able to explain the relationship between momentum and impulse. And lastly, they should be able to solve the relevant UTME questions relating to Newton's law of motion. Now, just as I said that today we shall be considering Newton's law of motion. Before we proceed, we need to understand that motion occurs in response to a force, which can either be a pull or a push. And we shall be starting with the Newton's first law of motion, which states that a body continues in its state of rest or uniform motion unless a net external force acts on it. This Newton's first law of motion is also known as law of inertia. Law of inertia. And inertia is the ability of an object to be in the state of rest. Having understood the Newton's first law of motion, we need to proceed to Newton's second law of motion, which states that the rate of change of momentum is directly proportional to the applied force. Mathematically, m into phi minus u over t is directly proportional to force F. M in this case is mass in kilogram. Phi is final velocity in meter per seconds. U is initial velocity in meter per seconds. While F is the force in Newton. If you can recollect from our first video, where we derived the definition of acceleration, we said acceleration is change in velocity over time, which is acceleration A equals phi minus u over t. Therefore, if we substitute for phi minus u over t we are having under this Newton's second law of motion, if we put A in place, then we are going to have ma is directly proportional to force F. If we introduce constant of proportionality, then our F will be equal to kma, where k is the constant. If F is 1 Newton and mass m is 1 kilogram and acceleration A is 1 meter per second square, then we arrive at force F equals ma. That is, force equals mass times acceleration. This is where they derive the formula for force equals ma. So it's a derivation from Newton's second law of motion. We have to take note of that as we may need it later. The next thing we shall be considering is the principle of linear momentum. we state that the total momentum before collision equals total momentum after collision. I repeat, the principle of conservation of linear momentum states that the total momentum before collision equals the total momentum after collision. And the mathematical expression can be given as m1u1 plus m2u2 equals m1 phi1 plus m2 phi2. The total momentum before collision is m1u1 plus m2u2, while the total momentum after collision is m1 phi1 plus m2 phi2. Hence, the total collision of an isolated or closed object remain constant. M1 in this case is mass of the first object, while U1 is the velocity of the first object, the initial velocity of the first object in meter per second. M2 is the mass of the second object in kilogram, while U2 is the initial velocity of the second object in meter per second. Phi1 is the final velocity of the first object in meter per second, while Phi2 is the final velocity of the second object in meter per second. I repeat, Phi1 is the final velocity of the first object in meter per second, while Phi2 is the final velocity of the second object in meter per second. Hence, we can say the total collision of an isolated or closed object remain constant. An isolated or closed object is the system in which no external force acts on it. So, a closed system is a system on which no external force acts on it. Having understood the Newton's second law of motion, we also need to consider some other applications of Newton's second law of motion. And the first one we shall be discussing here is momentum. Momentum is the product of mass m and velocity phi of the body. Its unit is kilogram meter per second. It is a vector quantity. Mathematically, momentum m equals m into phi minus u. That is mass times change in velocity. M in this case is mass in kilogram. U is initial velocity in meter per second, while phi is the final velocity in meter per second. Having understood the concept of momentum, the next thing we shall be considering is the impulse. The impulse of a body is the product of the force and the time t for which it acted. Mathematically, impulse I equals force in Newton times time in seconds. It is a vector quantity because it has both magnitude and direction. Its unit is Newton seconds. Newton seconds. Having understood the concept of momentum and impulse, the next thing we need to consider is the relationship between momentum and impulse. But before we proceed, we need to recall that Newton's second law of motion states that the rate of change of momentum is proportional to the applied force. If you write that is, and if you can recollect, we said the change in momentum, rate of change in momentum is given as m into phi minus u over t, then is directly proportional to force F. So if we change the proportionality sign to equality sign, then we have m into phi minus u over t equals F. If we cross multiply, that will lead us to m into phi minus u equals Ft. If we can recollect that m into phi minus u, that is the change in momentum, while F times T is the impulse. Therefore, from there, we can say impulse is equal to momentum, or momentum is equal to impulse. Now, having understood that momentum and impulse are equal to each other, we need to consider some sample questions from the UTME relating to this particular concept of momentum and impulse. And the first question we shall be considering comes from 1991, question 5. And the question goes thus: a body of mass 100 gram moving with a velocity of 10 meters per second collides with a wall. If after collision, it moves with a velocity of 2.0 meters per second in opposite direction, calculate the change in momentum. You are given the option A to be 0.8 Newton seconds, option B to be 1.2 Newton seconds, option C to be 12.0 Newton seconds, while option D is 80.0 Newton seconds. For the solution of this particular question, we need to first list out the given parameters. And the first parameters we are given from the question is mass M, which is 100 gram. We need to convert this to kilogram because we cannot use gram in calculation. The standard unit is kilogram. And we convert this 100 gram to kilogram by dividing it by 1000. And that will give us 0.1 kilogram. Then also from the question you are given initial velocity u to be 10 meters per second, while the final velocity is minus 2.0 meters per second. The minus here is indicating that the final velocity of the object is in opposite direction with the initial velocity, as stated in the question. So, having considered the given parameters, the next thing is to consider the necessary formula for the change in momentum, which is mass times change in velocity, that is m into phi minus u. Our m in this case is 0.1 into phi, which is minus 2, minus u, which is 10. So that will give us 0.1 times minus 2 minus 10 will give us minus 12. So we have 0.1 times minus 12, and that will give us minus 1.2 Newton seconds. Newton seconds, making option B to be the correct answer for this particular question. The next question to consider comes from 1987, number 4. And the question goes thus: a jet engine developed at thrusts of 270 Newton seconds when the velocity of the exhaust gases relative to the engine is 300 meters per second. What is the mass of the material ejected per second? Now, the solution to this particular question, just as we used to say, the first thing is to consider the given parameters. And from the question, we're given the impulse to be 270 Newton seconds. We're able to dictate that this 270 Newton seconds is impulse from the unit, is a clue to it, which is Newton seconds. Then you are also given velocity of the exhaust, velocity, to be 300 meters per second. Then you are asked to find the mass. In solving this particular question, we have to recollect that impulse is equal to momentum, and therefore impulse, which is force times time, will be equal to momentum, which is mass times velocity. Hence, we can say impulse is equal to mass times velocity, m times phi. So in substituting for this, our impulse is 270 Newton seconds equals mass m times velocity, which is 300 meters per second. So in solving this now, you can divide both sides by 300 meters per second, and that will give us mass m equals 270 Newton seconds divided by 300 meters per second, and that will result to m equals 0.9 kg, making option C to be the correct answer. for this particular question. The next question we shall be considering comes from 1993, number 6. And the question goes thus: a rocket burns a fuel at the rate of 10 kg per second and ejects it with a velocity of 5 times 10 raised to power 3 meter per second. The thrust exerted by the gas on the rocket is dash. So you are given option A to be 2.5 times 10 raised to power 7 Newton. Option B to be 5.0 times 10 raised to power 7 Newton. Option C to be 2.0 times 10 raised to power 2 Newton. Option D to be 5.0 times 10 raised to power 7 Newton. As usual, the first step is to write out the given parameters. And from the question, we're given mass. They said at the rate of 10 kg per second means that the mass is 10 kg, while the time is 1 second. Then you are also given the velocity to be 5 times 10 raised to power 3 meter per second. And we have to get force. In solving this, we have to recollect that impulse is equal to momentum, and therefore force times time will be equal to mass times velocity. That is m times v. So in substituting for this, our f is not given, times time, which is 1 second, is equal to mass m, which is 10 kg, times the velocity, which is 5 times 10 raised to power 3 meter per second. So you can divide both sides by 1 second, and that will give us force F equals 10 kg times 5 times 10 raised to power 3 meter per second divided by 1 second, making the answer to be 5 times 10 raised to power 4 Newton, making our final answer to be 5 times 10 raised to power 4 Newton, making option B to be the correct answer for this particular question. Now, the next thing is to consider the UTM sample questions on this Newton's third law of motion. And the example we shall be considering comes from will come from 2003, number 7. The question says a force of 100 Newton is used to kick a football of mass 0.8 kg. Find the velocity with which the ball moves if it takes 0.8 seconds to be kicked. You are given option A to be 32 meter per second, option B to be 50 meter per second, option C to be 64 meter per second, while option D is 100 meter per second. In solving this particular question, you have to write out the given parameter first. You have force, which is given to be 100 Newton, then the mass m, which is 0.8 kilogram. The time t is 0.8 seconds, while v is not given. So we have to record that impulse is equal to momentum, and hence F times t will be equal to mv. When we substitute our F is 100 Newton times t, which is 0.8 seconds, equals m, which is 0.8 kilogram, times v, which is not given. So you can make v the subject by dividing both sides by 0.8 kilogram. So 100 times 0.8 will give us 80. Divided by 0.8, that will be 100 meter per second, making option D to be the correct answer for this particular question. This question is still buttressing that momentum is equal to impulse. The next question we shall be considering comes from 1998, number 5. A ball of mass 0.15 kg is kicked against a rigid vertical wall with horizontal velocity of 50 meters per second. If it rebounds with the horizontal velocity of 80 meters per second, calculate the impulse of the ball on the wall. You are given the option A to be 3.0 Newton, option B to be 4.5 Newton, option C to be 7.5 Newton, while option D is 12.0 Newton. In solving this particular question, you write out the given parameters first. and you are given mass m to be 0.15 kg. The initial velocity is given to be 50 meter per second, while final velocity phi is 80 meter per second. So we have to recall that momentum is equal to impulse, and that means m into phi minus u, which is change in momentum, will be equal to impulse, which is force times time. So in substituting, our impulse can be got in terms of momentum, and that will be equal to m, which is 0.15 kilogram, into phi, which is 80, minus u, which is 50. So that will give us 0.15 kilogram times 30, and of course that will give us 4.5 Newton seconds, making option B to be the correct answer for this particular question. The next question we shall be considering comes from 2009, number 7, and the question goes thus. A body of mass 12 kg traveling at velocity of 4.2 meter per second collides with a second body of mass 18 kilogram at rest. Calculate their velocity if the two bodies coalesce after collision. Then you are given option A to be 1.5 meter per second, option B to be 1.4 meter per second, option C is 2.1 meter per second, while option D is 1.7 meter per second. Solution to this question. The first thing is to write out the given parameters. And from the question, we have the mass of the first subject, which is m1, that is 12 kg, 12 kilogram, while the initial velocity of the first object u1 is 4.2 meter per second. The mass of the second object is 18 kilogram, while the initial velocity of the second object being at rest is going to be 0. So u2 equals 0. Then since they said the two objects coalesce, that means they move together after collision. So their final velocity is unknown, and that is what they asked us to find. This particular question is buttressing the principle of conservation of linear momentum, meaning that the sum of initial momentum will be equal to the sum of the total momentum before collision will be equal to the total momentum after collision. So using the formula m1u1 plus m2u2 equals m1 phi1 plus m2 phi2. Then since they said after collision they move together, they are going to have the same velocity. Changing the formula to m1u1 plus m2u2 equals m1 plus m2 into phi, since the velocity is now common. So in substituting for the formula, our m1 is 12 times u1, which is 4.2 meter per second, plus m2u2, that will be 0. Since u2 is 0, so 0 times m2 is going to give us 0, which will be equal to m1, which is 12, plus m2, which is 18 kilogram, into phi, their common velocity. Then in solving this, 12 times 4.2 will give us 50.4, which is equal to 30 phi. That is 12 plus 18 phi. That will give us 30 phi. So to make phi the subject, we can divide both sides by 30 to get phi equals 50.4 divided by 30, making our phi to be 1.68 meter per second, making option D to be the correct answer. When we approximate 1.68, we get 1.7 meter per second, making option D the correct answer for this particular question. Now, the next thing we shall be considering will be the Newton's third law of motion. Having understood the Newton's first and second law of motion, we need to consider the Newton's third law of motion, which states that to every action there is equal and opposite reaction. For example, if you consider the gun and the bullet, the momentum of gun is equal and opposite to that of bullets. And mathematically, that can be given as mg equals minus mb, that ub. Mg is the mass of the gun, while ug is the velocity of the gun, mb is the mass of the bullet, while ub is the velocity of the bullet. The next question we shall be considering now comes from 1984, number 36, and the question goes thus. A gun of mass 2.0 kg fires a bullet of mass 1.6 times 10 raised to power minus 2 kg due to east. If the bullet leaves the nozzles of the gun with a velocity of 150 meter per second, what is the recoil velocity of the gun? Then you are given option A to be 150 meter per second due east. Option B is 1.2 times 10 raised to power minus 4 meter per second due west. Option C is 1.2 times 10 raised to 1.2 meter per second due west, while option D is 1.2 meter per second due east. Option E is 150 meter per second due west. Now, for this particular question, this is an application of Newton's third law of motion, which is telling us that to every action there is equal and opposite reaction. So the momentum of the gun in this case is going to be equal and opposite to that of the bullets. So as usual, the first thing to consider here will be to write out the given parameters. And from the question, we have the mass of the gun to be 2 kg. Then we are also given the mass of the bullet to be 1.6 times 10 raised to power minus 2. Then we are given the velocity of the bullet to be 150 meter per second, while the velocity of the gun is not given. That is what they ask us to find. Now, using the derivation from the Newton's third law, that the momentum of the gun is equal to momentum of the bullet, equal and opposite to that of the bullet. That means we are going to use the formula mg, that is the mass of the gun, times ug, velocity of the gun, equals minus mb, mass of bullet, times ub, that is velocity of the bullet. And in substituting for that, our mg is 2 kg times ug, which is not given, equals minus of mass of bullet mb, which is 1.6 times 10 raised to power minus 2 kilogram, times ub, that is velocity of the bullet, which is 150 meter per second. So you can make ug the subject by dividing both sides by 2 kg, and that will give us ug equals 1.6 times 10 raised to power minus 2 kilogram times 150 meter per second divided by 2 kilogram. And of course, that will make our ug to be 1.2 meter per second due west, because it is going to be in opposite direction. And since they said that of the gun move due east, that means that of bullet move due east, that means the velocity of the gun will be the opposite of east, which is west. And that will make option C the correct answer. Thank you. The next thing to consider is the forces acting on the body inside a lift. For an object inside a lift, two forces act on it. The first is the weight of the object W inside the lift, and the second is the reaction R on the floor of the lift. Now we have some formulas depending on the status of the elevator, and the first we shall be considering is for a stationary elevator. For a stationary elevator, the tensional force will be given as mg, which is also equal to reactance. For an elevator moving upward, then the tensional force T1 will be given as m into A plus G. Of course, that is derived from the sum of the weights and the reaction. And the third condition we shall be considering will be for an elevator moving downward. For an elevator moving downward, the tensional force will be given as m into G minus A. And the fourth condition we shall be considering is for an elevator falling freely. For an elevator falling freely, then the tensional force is 0. The tensional force is 0. Now, the next thing is to consider some sample questions from the UTME. And the first question we shall be considering on this segment comes from 2015, question number 4. And the question goes thus: what force has been exerted on a mass of 60 kg to give it an acceleration of 10 meters per second square upward? Then you are given in brackets that G equals 10 meters per second square. Now, you are given option A to be 600 Newton, option B is 1200 Newton, option C is 400 Newton, while option D is 300 Newton. The solution to this question: the first is to write out the given parameters, and from here you have the mass to be 60 kg. Then the acceleration A is 10 meters per second square, while acceleration due to gravity is 10 meters per second square also. So if you can recollect, for an elevator moving upward, we said the total tensional force will be m into A plus G. So in applying this formula here, you have F, tensional force, which is equal to m, that is 60 kg, into A, the linear acceleration in the lift, that is 10, plus acceleration due to gravity G, which is also 10. Of course, that will give us 60 times 20, which is equal to 1200 Newton, making option B to be the correct answer for this particular question. The next question we shall be considering comes from 2002, number 9. And the question goes thus: a body of mass weighing 80 Newton stands in an elevator that is about to move. The force exerted by the floor on the body as the elevator moves upward with an acceleration of 5 meters per second square is dash. You are given option A to be 160 Newton, option B to be 120 Newton, option C to be 80 Newton, while option D is 40 Newton. They were given in brackets that acceleration due to gravity G is 10 meters per second square. Now on to solution. For this particular question, you are given the force, which is 80 Newton, the tensional force. You are given the weight to be 80 Newton. And weight is equal to mass times acceleration due to gravity. So we can get our mass from the weight. by substituting for the acceleration due to gravity and weight. So W equals mg. Our m is not given, is what we want to find now, times g, which is 10, equals W, which is 80 Newton. So we can divide both sides by 10 to make m the subject of formula, and of course we get m equals 80 kilogram. So after getting our m, then we can use the equation for the tensional, the formula for the tensional force in an elevator moving upward, which is given to be F equals m into a plus g, and we've been given our a, acceleration in the lift, to be 5 meters per second square. So if we substitute in F equals m into a plus g, our F will be m equal to m, which is 8 kilogram, into a, which is 5, plus g, which is 10. So that will give us 8 times 15, that is 120 Newton, making option B the correct answer for this particular question. The next question we shall be considering comes from 1987, number 6, and the question goes thus: an accelerator of mass 4,800 gram is supported by a cable which can safely withstand a maximum tension of 60,000 Newton. The maximum upward acceleration of the accelerator can have is dash. Then you are given option A to be 2.5 meters per second square. Option B is 5.0 meters per second square. Option C is 7.5 meters per second square. While option D is 10.0 meters per second square. Solution. Now, the first thing is to write out the given parameters. And we are given our m to be 4,800 gram. Then the tensional force is 60,000 Newton, while the acceleration due to gravity is 10.0 meters per second square. Then we are not given the acceleration in the lift, which is a. That is what they ask us to find now. For upward movement of an elevator, we have the tensional force, total tensional force, to be m into g plus a. In substituting for that, the tensional force will be which is 60,000 Newton, is equal to m, which is 4,800 kilogram, into acceleration due to gravity g, which is 10, plus a, which is not given. Then we can divide both sides by 4,800. That will give us 60,000 Newton divided by 4,800 kilogram equals 10 plus a. 60,000 divided by 4,800 is equal to 12.5, which is now 10 plus a. We can make a the subject by transferring 10 to the other side to get a equals 2.5 minus 10. And of course, that will give us 2.5 meters per second square, making option A the correct answer. The next question we shall be considering comes from 1986, number 15. And the question goes thus: a 1,000 kilogram elevator is descending vertically in an acceleration of 1.0 meters per second square, vertically with an acceleration of 1.0 meters per second square. If the acceleration due to gravity is 10.0 meters per second square, then the tension in the suspending cable is dash. You have option A to be 1.0 Newton, option B is 10.0 Newton, option C is 9,000.0 Newton, while option D is 11,000.0 Newton. Now, solution to the question. The first thing is to write out the given parameters. And from the question, you are given acceleration in the lift, which is 1.0 meters per second square. You are given the acceleration due to gravity, which is 10.0 meter per second square also. Then we are given the mass m, which is 1,000 kilogram. Then, since the side is moving downward, this is descending. The elevator is descending, means it's moving downward. And the formula for that, if we can recollect, is the tensional force for an accelerator moving downward or descending will be T equals m into G minus A. So our T is equal to m, which is 1000 kg, into G, acceleration due to gravity, that is 10, minus A, which is 1.0. And that will make our answer to be 1000 times 9. 10 minus 1 is 9, making our answer to be 9000. So making option C to be the correct answer for this particular question. In summary of the presentation so far, we started by making us realize that motion may be due to a response to a force, which can either be a push or a pull. After that, we proceeded to the Newton's first law of motion, which states that a body continues to be in the state of rest or uniform motion unless an applied force is applied on it. We stress that Newton's first law of motion is also known as law of inertia. And we defined inertia as the tendency of an object to be at the state of rest. After that, we proceeded to Newton's second law of motion, and we stated Newton's second law of motion as that the rate of change of momentum is directly proportional to the applied force. And from there, we are able to get the derivation for the formula of force, that force equals mass times acceleration. Also, through the Newton's second law of motion, we are able to realize that momentum is equal to impulse. We considered momentum as the product of mass and velocity of an object. We said momentum is a vector quantity because it has both magnitude and direction, and the unit of momentum is kilogram meter per second. After that, we also discussed impulse. We said impulse is the product of force and time. We said it's also a vector quantity because it has both magnitude and direction, and its unit, the unit of impulse, is Newton seconds. Through this Newton's second law of motion, we are able to prove that impulse is equal to momentum. So we can calculate momentum from impulse parameter. Likewise, we can calculate impulse from momentum parameters. After that, we also discussed the law of conservation of linear momentum. And the law states that the total momentum before collision is equal to the total momentum after collision. And after that, we were also able to discuss the Newton's third law of motion, that the law says to every action there is equal and opposite reaction. And the example we consider for that is that the momentum of gun is going to be equal to and opposite to that of bullet. Momentum of gun is going to be equal and opposite to that of bullet. So therefore, the mass of gun times velocity of gun will be equal to minus mass of bullet times velocity of bullet. After that, we also consider the forces in a lift or an elevator, and we stress the issue of tensional force. We stated 4 different conditions the lift can be. That for a stationary lift, the tension is going to be equal to the weight, which is also equal to reactant, which is also equal to reaction. The tension is equal to weight, which is also equal to reaction. Then we also talk about the second condition, when the lift is moving up. For upward movement, the tensional force will be the sum of the weight and reaction, and therefore tensional force F or T is going to be M into G plus A. The third condition of the lift we talked about was when the lift is descending or moving down. And we said in this case, the tensional force is going to be M into G minus A. M into G minus A. And the last condition, which is the fourth condition of the lift we talk about, is when the lift is falling freely. When it's falling freely, then the tensional force is going to be 0. Our next video will be on centripetal motion, and there we shall be considering the definition of centripetal motion as well as the necessary term associated with it, such as the centripetal force itself, the angular acceleration and velocity, as well as the relationship between angular and linear velocity, between angular and linear acceleration, and lastly we shall consider the sample questions from UTME that are related to this centripetal motion. So I urge you to look forward towards our next video. I also urge you to please subscribe to our YouTube channel, like our video, and share our video with your friends, as we promise to give you more interesting lectures relating to UTME WAEC NAPTIP exam. So thank you.